Hello, welcome to the third installment for this tutorial series. In this episode, we will be focusing on integrating our item database entries to our player's inventory. Before we begin, I would like to inform you that since our previous episode, I have made some minor changes to our project. As you can see, I have created an image file and imported the file into the item icons folder. The image file's dimension is exactly 48 by 48 pixels, and I have chosen a dark gray color. You can do the same using any image editor available to you. This image will represent empty slots in our inventory. I have also made some changes to our item list in the player inventory scene. I have changed its size to 630 by 380, and set its position to 130 by 30. Then, I added a child button node under the panel node, and named it as button_load. Then set its text property from the inspector to load. I've also set its size to 90 by 50, and its position to 20 by 40, from the inspector. I have also updated our item database. You may download the updated JSON file of our item database using the link that I will provide on the video's description below. Now, we may continue coding our inventory. I will now create a new script. On the first line of the script, let's extend the node class. Then save the script file into our scripts folder. I will name the script file as global_player. Now, I will create a variable which will hold a string data, and name it as URL_player data. I will then initialize the variable with the following file path. This path will be located on your computer's default app data folder if you are on Microsoft Windows operating system. In this directory, we will be saving the playerdata.bin file, which will store our saved items on our player's inventory. You can quickly access the directory through the Run command window by pressing the Windows key, +R, if you are on Windows. Then, type in the following parameters, as a single line. This will open the Windows Explorer, and direct you to the user environment directory, where we wish to save our player data file. By default, the directory should be empty. Next, I will declare another variable named inventory, and will initialize it as an empty dictionary. This variable will store our inventory into a dictionary format, which we will load from the player data file. I will then declare a new variable named as inventory_max slots, which will hold an integer value. I will initialize it with the value of 40. This will represent the maximum available slots in the player's inventory. And finally, the variable player data with the keyword onReady. I will then initialize it by calling the global data parser function, load data, then pass the URL_player data variable as its parameter. The function will then return a dictionary which will be the whole structure of our player data file. From this structure, we will be able to derive our inventory dictionary later on. Now, let us create our first function for this script. The function's name will be load_data. The load data function will handle operations that will load our player data file contents, which will be then parsed into our inventory dictionary variable. This data will also handle the creation of our player data file, if the file does not yet exist. When the function is called, we will check if the player data variable is null. meaning the global data parser load data function has returned a null value, which also means that the player data file does not yet exist. Now, if the result of the condition is true, we will then begin to construct our default player data dictionary using a for loop, in range from 0 to the value of our inventory max slots variable, which is 40. The result of the iteration will be slot numbers 0 to 39, which is a total of 40 slots. We will then store the newly constructed dictionary into our dictionary variable, with the initial value of the key named inventory, which will then hold the slot numbers 0 to 39 as its subkeys. The subkeys will then contain the fields ID, which will hold the item's ID, with the default value of item ID 0, which is an empty slot item referenced from our new item database, and amount, which will hold an integer representing the total amount of such an item in the player's inventory. We will set a default amount of 0 for each empty slots. Now, if the result of the condition is true, we will then begin to construct our default player data dictionary using a for loop. After the loop's iteration, we will then create our player data file. We do this by calling the global data parser function named writeData, and passing the variables URL_player data, and the dictionary variable, as the function's parameters. Then, we will reference the inventory variable, to the value of the dictionary variable we previously created. Now, if the result of the previous condition is false, meaning we already have an existing player data file, we will simply reference the inventory dictionary, to the value of the dictionary variable player data, and its inventory key. Now, let us create our ready function. By default, we would want the player data to be loaded when the game starts. And finally, let us begin adding our global player script into our auto load sequence from the project settings. As I've mentioned in the previous video, when adding scripts into the auto load sequence, the load priorities of the scripts are very crucial to properly execute our game. The global player script must be positioned to the left. You can do this by clicking the arrow down button from the row of the global player script. Now, let us test run the game. At this moment, after running the game, if you open the directory of our player data file, a new file will be created named playerdata.bin. You can open the file using a text editor. As you can see, our default player data has been created and filled with the default data structure which we have created from the global player script. Now, let's open our item database script and delete the ready function code block, since we won't be needing it anymore. Then, open the player inventory script, and under the ready function, delete the for loop block, since we will now be populating the item list in a different manner. Now, click the button _load node to set it to active. Then switch to the node tab, which is located next to the inspector tab. We will be adding an event handler to the button load, whenever it is pressed. To do this, from the signals, choose pressed, then click connect and highlight the scene's default node, then click connect again. This will automatically create a new function in our player inventory script. This new function will be called every time the button load is pressed during runtime. Now, on the button load pressed function, we will initially clear our item list. To do this, we type in item list.clear. Then, we will construct yet another for loop, in range of 0 to the value of the variable inventory max slots from our global player script, which is 40. Inside the for loop, we will declare a dictionary variable and name it as inventory item, which will reference a value from the global player script variable inventory, using its dictionary key based on the incrementing value of the variable slot. Then, another dictionary variable named item metadata, which will then store a dictionary based on the returning value from the global item database script function, getItem. We will also set the function's parameter to the inventory item dictionary field named ID. Now, we will create a variable named icon, which will load and store the image file path of the current item, and will be used as its icon for the item list. And finally, a variable named amount, which will store an integer, and will be based on the amount of the specific item the player currently has, which was loaded from the player data file. Remember that our generated player data file had item IDs 0, which is an empty slot, and each also had a default amount of 0. Now, back to our item metadata variable. We will add a new field to its dictionary named amount, and will reference the value of the variable amount we just created. Then, the following conditions will check if the currently iterated item ID has the value of 0, or if it's stackable. If so, we will change the value of the variable amount from an integer to a string, followed by a single empty space. And finally, we may now begin populating our item list with information we have retrieved from our player data file. Now, let's test run our game. Click the load button to trigger our button load pressed function in our player inventory script to populate our item list. Now, since we only have empty slots, let's see if we can load actual items from our item database. At the moment, the only way to achieve this is to manually edit our player data file using a text editor, and input our desired item IDs. In our player data file, I will edit the following slots. After editing, don't forget to save your changes on our player data file. Then let us rerun our game and check if our items will load accordingly. Perfect, this now concludes this video. In the next upload, we will be creating a debug feature to programmatically add items to our player data. We will also create functions to delete and move our items to different slots in our item list, then be able to save our inventory item list's current state to our player data file. Thanks again for watching. Leave a like and feel free to share the video to your friends who are also into game programming. Subscribe and toggle the bell notification icon to be informed of the latest video uploads. For questions, feedbacks, and suggestions, kindly use the comments section below. See you soon.